I will be coming to that, was able to get into the brain and protect the substantia nigra neurons against those toxins who generally cause Parkinsonism in the people and who has been shown to cause Parkinsonism in the rat and mice model. So I'm not going to read this slide, it goes on, but this is the bottom line. Right now it is ready to go for clinical trial, and I'm very glad that in audience we have two people from bioscience, Rene and Tom, and we are hoping that they are processing doing all the other formality to bring this compound to the clinical trial or to the clinics be available for us. Now, at this stage, that is where I'm supposed to put the papers. I have been asked many questions from the people or relatives of the people who are suffering with the disease or the doctors that a CoQ10 trial was run, and in 2011 a clinical trial was dropped because it was not successful. And that trial was with oil-soluble coenzyme Q10 only one coenzyme Q10, nothing added to that. And it was pretty big trial, but they did not find any protection. So how do you think, what is your explanation for that? And how is your formulation, which is not just CoQ10, it is CoQ10 and vitamin E, a pro formulation of vitamin E, combined together in a water-soluble formulation. So what is the difference? And I have some explanation here. I wish the previous speaker was also here. I wanted to talk, but she has to go and attend the clinic. That the doses is the key thing. When I checked the literature, 3 papers published with oil-soluble formulation available for which the clinical trial was done, this was the dosing given to the animals. 200 to 1600 milligram per kg per day. It is a very high dose. A human being generally average 70 kilogram patient, if you translate that dose, it becomes minimum of 14 grams a day to maximum of 112 grams a day. So if it is showing any protection in the animal model at this dose, if you translate that dose, it is impossible to give this dose to anybody. In fact, in the clinical trial, they went initially for 1.2 grams per day, and then in the latest one, they went for 2.4 grams per day. So one of my hypotheses, or our collaborators' hypothesis, is that it may not have worked because of this dosing. We are not reaching that concentration which is supposed to work. So we do not have data, at least in published, there must be data which is not published, that what part of it goes in the brain and how much it gets elevated in the brain after feeding. So there were some major problem with that. Also, there is no cellular study with oil-soluble formulation anywhere published. As against that, this UB-Sol-Cu formulation, which has vitamin E and coenzyme Q both, the doses we got, I showed you the result today, were 5 to 6 milligram per kg per day. And that will translate into 350 milligram to 420 milligram per day, which is easily given dose to the people. I mean, by FDA, 1.2 gram per day coenzyme Q can be taken. We are well below this one, that limit. So our hope is that if this formulation comes into practice or comes into clinic, again, I can't predict anything what will happen in the clinics, but based on our animal results and dosing and clear effect on behavior as well as histology of the brain, we think that this dose should be able to halt the progression of the disease right then and there. So this is what we are hoping for. So with that, this is the animation for comparison of the capsules. Okay. So 280 capsules will be worth only 1 capsule for this. Well, do you require lots of this? You require very little of this. With that, I am just a communicator, I professor, I teach, which students don't like all the time teaching. But I do my research and I am a communicator. Most of the work is done by our graduate, undergraduate students and people in NRC, people in Dr. Cohen's lab. I could not get a picture from Cohen's lab, but they also contributed in the behavioral work. So this is the previous students. Malika Somaya Julu did the prophylactic study before and she completed her PhD doctorate, and she's doing her postdoctoral training. These are the people who are in medical school, or Katie is completing her master's program right now. And these are the current group of people. So Kritika has taken over the graduate studies. She is the next master's student going to doctoral study. And these are the undergraduate students who work with all these mice. Particularly, Jessica worked with mice, and Kate and Samantha also work with the mice. Kate and Samantha work with the rats for the staining and everything. And there are other people also involved. We had a postdoc for a short time. She was also in the lab, Alison, and she's now teaching in a college. And of course, we should acknowledge these brave people who sacrificed their life for this wonderful study. And of course, it is my pleasure, and I'm really pleased that all the way from Ottawa, Dr. Sikorska is here in this conference, who was the inventor of this product in NRC. So she's here, and she will be coming after the jury to give a prospective view of this formulation and what this could do. And of course, very lucky to have Dr. Cohen and his co-workers who did this study on the behavior, and he will be also addressing you in a moment. With that, funding is the one thing. Again, I stress that local group of people. Initially, to launch this project, Dr. Toldo and Toldo Foundation gave us $20,000 very in the beginning, 2005, to start this project. And then, of course, Mr. Sachi and his family donated for this machine. Locally, we are so grateful to all these people. As well as Canadian Institute for Health Research, CIHR, is the major funding agency behind this work. We got that renewed grant for 6. So total, they have been funding for 6 years. And of course, Michael J. Fox Foundation with Zymes. They are helping this project to bring it to clinics, and we are so grateful for this. And that was only Parkinson's story. There are a lot more people who are working in the lab on the cancer project and stroke project as well. They are all here. I deliberately wanted to bring these people here for this conference because I wanted to see this, what is going on, and also I wanted to warn them that when we will be growing older, which is not very far, they will be the one who will be taking care of us, either in the clinic or at home or in anywhere. So these are our hope, as Mr. Sachi told them. And these are our future people, our future generation. May I ask all the students to stand up, please, on the back bench. So with that, I, again, acknowledging the local investment and all the investment you are doing in the future generation, I thank you all for your attention. And at this moment, I will be setting up some videos, and Dr. Cohen will say something about importance of the behavioral studies in this model. Thank you.
Thank you very much, Dr. Pandey, and it's such a delight to be here and to see all of you and to tell you some of the exciting research that we're doing. I lead the behavioral assessment group. We have rats in our lab, and unfortunately we do have mice. And half of the students in the back are associated with my laboratory. And they're the ones actually that should be up here and telling you exactly what they're doing, because I don't run the rats anymore. They run the rats and the mice and do all the video. And we're going to show you just a few video clips. So I'm not going to go over any of the data with you. That's rather laborious. But I want you to walk away with what animals do and the kind of behavior that we're looking at. But I want to tell you that first of all, for those of you who love rats and for the few of you who love mice and don't want to hurt them very badly, We don't hurt them very badly. The amount of neurons that are damaged is around 50% of the substantia nigra. And if you look at somebody that has lost about 50% of their neurons in that area, you would be hard put to tell that they had lost that amount. And you know, when those of us that do go to a clinic that do have symptoms of Parkinson's or other neurodegenerative diseases, we've lost a lot more neurons. So basically, what we're really looking at are some very subtle effects. Here is, for two reasons. We don't want to hurt our animals. Okay, we don't want to give them so much neurotoxin that they are really suffering. That wouldn't be right. The other reason, of course, is that if we can detect some of the behavioral deficits early, and early detection is always important, then if we can intercede to protect the remaining neurons, that would be even better than when we can intercede to protect the 20% that are left. And as Dr. Pandey told you, if we can protect 20% of those neurons, many of us can live very good lives. And so that's basically what we're hoping to do by developing these kind of behavioral tests. Perhaps this can be translated into clinical work that can be used to look at early detection, both histologically or neurochemically, as well as behaviorally. So I'm not a doctor. Maybe I could help rats that have problems, but we're really relying upon our fine professional group of doctors to help us. So I'd like to just show you a few of the tests that we use, and so that you can walk away and see what a rat can do. Now, we're not going to let humans do these kinds of tests, okay? So this test is an animal going up a beam, and we look at how it goes and how his legs slip, okay? These are rats.
Coming in full.
He doesn't have any money.
So I think we're going to have to start using the glass again.
And it's just somebody in the lab talking.
But I put them back on and made sure that they went for a total of 2 minutes.
Okay.
That's Cohen. That's Cohen who's doing this. Okay. So now we have a ladder. We climb up a ladder, and one of the beams is broken. So we have a camera underneath, and this rat has already experienced this. Now, let's see if you can see this. He's going to watch. He's testing. Boom! Oh, the beam broke. Okay. So what we're doing here is we're trying to see whether the animal can anticipate when this rung is going to break, and then we expose the animal to this ladder where the rung's not broken, and we see how well it can recover. This is one of the tests we hope to use for our Parkinson's research. Which one is this one now? Oh, this is the pole that. So we put this animal on the top of the pole, and we say, okay, come on now. You don't want to be on the top of this pole. See how long it takes him to come down. Now, I can't tell you whether this animal's been injected or not, but so what we do is we run blind tests. We don't want to know who's been injected and who hasn't. He's down. Okay. Is that it?
You have another ladder.
Another. Okay. Well, sure. This is what our ladder looks like, a slightly inclined ladder.
It's not a video, it's a picture.
No, it's just a picture, and the rat just runs along here, goes to the end, and when he gets to the end, he gets into his little holding cage, and he gets a little piece of apple. So he's very happy. Well, I want to thank you very much. This is just some of the work that we do. We have other tests that we're doing, and I want to thank Dr. Pandey for letting me collaborate with him, Dr. Sikorska for her development of this wonderful product that we hope will be helpful to all of you. And I would like now to turn it back over to Dr. Pandey.
Thank you, Jerry.